Hi everybody, and thanks for joining us on this week's episode of Up in the Air. I'm Quinn Leese, and joined today is Mike Kwasnick.
Thanks, Quinn. We have a lot of interesting stories this week, such as the world's longest lightning strike, Jupiter's moon Europa, and forecasting improvements on typhoons.
Sounds great, and as always, we'll have Lydia stop by the climate wall to have details on the weather that we can expect for the near future.
We'll have all that and more coming up, but first, here's Update in the Air.
This year has offered an unusual number of opportunities for Japanese typhoon forecasters to test and evaluate their skills and abilities as powerful storm plummeted the nation. Despite all the advanced technologies available, it is still difficult to predict when a typhoon will form, where it was going, and how strong it will be. Researchers and forecasters across the world are racing to apply state-of-the-art equipment from high-performance radars to supercomputers, just to improve typhoon forecasting. Images of the typhoons provided by weather satellites generally show the eye of the storm, surrounded by an eye wall, which are a huge vertical wall of clouds. But little is known about what actually happens inside a typhoon. A new radar has been deployed measuring the vertical cross-section of the eye wall. This feat was made possible by a phase array radar that can scan the entire cloud quickly from top to bottom. The sophisticated radar makes it possible to monitor detailed changes in the clouds every 30 seconds. Conventional weather radars can only be used to get a picture of the cloud in cycles of 5 to 10 minutes.
The Earth appears to be losing oxygen, and scientists struggle to figure out why. According to new data and research released, the Earth has lost 1% of its oxygen over the last million years. This is not cause for concern with respect to life, but it is an interesting topic to dive into. For a long time, scientists have tried to recreate the atmosphere of the distant past in order to understand the Earth better. Unfortunately, a lot of the model simulations used by the researchers give many different possible answers, and it is not known how constant the oxygen levels of the Earth have been. The conclusion from the study suggests that 0.7% of the oxygen in the air lost in 800,000 years was due to processes that remove oxygen from the air.
It has been an active fire season in Siberia, Russia this year, and NASA has captured some stunning photos from space that show just how widespread these fires have been. Huge plumes of smoke can be seen streaming across the northwestern regions, and you can see on this modest image detected unusually warm temperatures associated with the fire. According to a press release by NASA's Earth Observatory, smoke from the fires, which have been lofted high into the atmosphere, making it visible on satellite imagery. The tops of some of these smoke plumes have reached almost 30,000 feet this past week, according to data from the Cloud Aerosol LiDAR and Infrared Pathfinder satellite observations, better known as Calypso. Several million acres have burned in the recent months in Siberia, destroying forests that may take decades to centuries to regrow. With the launch of the GOES-R in November, we will eventually be able to see some high-resolution images to come in the near future.
Exhilarating Europa, Jupiter's ice moon, is thought to have water plumes spewing from its icy surface. Long believed to have an ocean underneath the cracked, icy surface, this is exciting news to add to the already awesome satellite. It is presumed to be similar to Saturn's moon, Enceladus, which has icy geysers shooting particles from its surface. The news enhances NASA's push to explore Europa, and they are hoping to find evidence of life from this ever-exciting rock.
Researchers identified lightning bolts in Oklahoma and France as the longest on record and warned that their discovery could alter a traditional thinking of when it is safe to go outside after a storm. A 2007 storm in Oklahoma produced a lightning bolt nearly 200 miles long, while a 2012 storm in southern France produced a single flash that lasted 7.74 seconds. Both events were added Wednesday to the list of weather extremes kept by the World Meteorological Organization. Timothy Lang, a researcher at NASA's Marshall Space Flight Center in Huntsville, Alabama, said the recorded Oklahoma lightning bolt streaked from Tulsa, which is located near the Arkansas border, to near the Oklahoma Panhandle. The bolt started at an altitude of 6 miles and reached the ground in a number of places. A researcher in Colorado said that the streak, and Land said the length could change thinking about safety and about the storm. Remember, if thunder roars, head indoors.
The Earth should have been much colder during its primal life. However, it was not. Scientists thought they understood why, But now a study explaining the importance of strong greenhouse gases helped. The sun was thought to be 10 to 15% dimmer than today, and the primal life forms on Earth needed the extra greenhouse effect. For decades, scientists thought it was methane, but new evidence suggests that methane really was not the compound they are looking for. A large amount of sulfate was found in rock record, and it directly destroys methane. Now there is a void in the saving gaseous grace for the early Earth, and scientists are working hard to figure it out. We'll be back in a moment with more. Thanks for tuning back in.
We now have a special feature on winter extremes in the United States.
The United States has experienced two extremes on opposing coasts in recent years. While the West Coast has been in a state of record drought, the East Coast has been in a state of record cold. While there are many factors that control the prevailing climate of a location, a measure called the Arctic Oscillation and its fluctuations can in part help to explain these two extremes in the U.S. The Arctic Oscillation is a climate pattern characterized by winds circulating counterclockwise around the Arctic at around 55 degrees north latitude. The Arctic Oscillation consists of two distinct phases, a negative and a positive phase.
In the positive phase of the AO, pressure in the Arctic is relatively low compared to the pressure in the mid-latitudes. This pressure gradient keeps the jet stream farther north, which allows storms to travel farther north. This causes higher precipitation amounts in places like Alaska, Scotland, and Scandinavia. Additionally, the western U.S. and Mediterranean have drier conditions, and the eastern U.S. experiences warmer temperatures. In the negative phase of the AO, pressures in the Arctic are relatively greater than those over the mid-latitudes. This causes kinks or dips in the jet stream, bringing cold air farther south. In a typical negative AO phase, mid-latitudes experience colder temperatures and increased storm activity.
Since the mid-1990s, a trend in more frequent negative AOs has been observed. This is a phenomenon that has large-scale implications for the U.S. climate, as evidenced by the effects of negative Arctic oscillations. While this trend in negative AOs is not fully understood by scientists, research in the areas of sea ice loss, the influence of snow cover, and natural decade variability are being conducted in the attempt to explain the phenomenon. Interestingly, though, while the past 2 years have been more so in the positive phase of the AO, helping to explain the extreme drought in the western U.S., the eastern U.S. has experienced record cold and snowfall amounts which go against the basic understanding of a positive AO. While the majority of the northern hemisphere's mid-latitudes enjoyed warmer than usual winters, the extreme deviation in the eastern U.S. was caused by an eddy in the polar vortex. Essentially, a portion of the Arctic Oscillation behaved as though it were in a negative phase. This eddy brought cold Arctic air from the north, causing the eastern U.S. to have a climate more consistent with that of a negative phase AO.
It is worth noting that another oscillation known as the North Atlantic Oscillation is closely related to the Arctic Oscillation in that it describes the varying pressure gradients in the northern latitudes and the resultant effects on temperature and storm tracks across the continent. The NAO is another valuable measure to take into account to help explain the current extremes on the U.S. coast. The negative NAO that we are currently experiencing is consistent with the bitter cold on the East Coast.
Paying attention to the Arctic Oscillation can give an indication of what the coming weather may look like. Positive phase AOs bring warmer, more moderate weather to the East Coast, while negative phase AOs tend to bring cold and stormy conditions. As our understanding of the driving factors behind the fluctuations in the Arctic Oscillation increase, so will our understanding of climate change. For Up in the Air, I'm Ann Balog.
And I'm Matthew Strasser.
And I'm Zach Ellis.
Welcome back to the show, everybody. It's about that time again where we have Lydia Knox standing by at the climate wall. Lydia, how are we doing?
We're doing pretty well. I've definitely noticed those fall temperatures really dipping down a bit over the past weekend. I noticed that it was much cooler and much more comfortable in terms of the sleeping conditions. Did you guys notice the same?
Yeah, we did. It's actually starting to get a little bit chilly at night where you start to have to get some pants on.
Yeah, exactly. I actually have to get my AC out of my house and probably turn on the heat now. But our fall foliage report is looking to be a little bit more colorful than last week. Right now, portions of Maine, New Hampshire, and even into Vermont and New York are seeing a little bit more of those red, yellow, and even orange hues, which is great during this fall season. Our next week's air pattern right now, we see this big trough towards our west, and that'll be moving out throughout the mid of October, and then this big ridge should move out past towards our east later on in this month. That's setting us up for these above normal temperatures in the beginning of October, so much of the eastern half of the United States are seeing those. You can see this tighter gradient towards the middle of the country, and then towards the west we see those below normal temperatures, which is where that deep trough was dipping down. Our precipitation outlook right now looking a little bit drier towards the eastern half of the country. Parts of Pennsylvania are seeing a little bit below normal precipitation, which is definitely not what we want at this time of the year. And then we see that above normal precipitation is expected throughout the northwestern and western portions of the country. Fortunately, California is even seeing a little bit more of this above normal precipitation, which is definitely needed since they have been in drought conditions for a long time now. Our drought monitor even showing those severe conditions are still persisting throughout much of California, near San Francisco, Las Vegas, and even Los Angeles, all experiencing those same conditions. Over towards the eastern half of the United States, portions of Massachusetts are seeing a little bit more of a severe drought, even into New York, and much of Pennsylvania will be seeing more of those slight to moderate drought conditions. But that's all I got at the climate wall for now, guys. Back to you.
Thanks, Lydia. That's all we have for this week's episode.
Until next week, I'm Mike Wozniak.
And I'm Quinn Leese.
We'll see you next week up in the air.